Okay, I'm going to do this problem from the 2018 free response test. This is a very nice simple harmonic and momentum problem. So what you have here is you have the single block, and it's oscillating back and forth, no friction, and this is the equilibrium position. And then at one point, when it passes through the equilibrium position, this other block is dropped on it, and then they start oscillating as one system back and forth. Okay, so the first question says, determine the ratio between the period of the two-block system over the period of just block P. Okay, so the equation for a period of a mass on a spring is 2 pi root m over k. Okay, so this is actually pretty simple because the mass of this block is just m. The value for the spring constant is k. So that's what your period is for the single block system. Now the period for the two block system is 2 pi root 3m, and it's 3m because it's the total mass, 2m plus m is 3m over k. But now I want to find the ratio. So I'm going to do that over here. So TPQ over TP is equal to 2 pi root 3m over k over 2 pi root m over k. I'm going to cancel some things out. I'm going to cancel my 2 pi's out. I'm going to cancel my root k in the denominator. And this root m also cancels. So what am I left with? Root 3. Okay. On the test, this question, just part A, so this is a 7-point question, it says. This question, part A, was worth just 1 point. Okay, part B, the paragraph. Okay, so the figure, okay, so this is what I'm dealing with. And basically I want to compare the amplitude from this mass, whatever it reaches. So I'm going to call that, this is the amplitude of P alone. Okay, and it goes back and forth. And the question saying is, when this is dropped on it, is it going to reach the same amplitude, or is it going to be smaller? Is it going to be, over here somewhere? Or is it going to go even farther and go past the original amplitude? Okay, so this class is called physics because this is about the physical world, and you should try to picture what's happening physically. Okay, so what does your gut tell you about what's going to happen when this thing is plopped on? Okay, some of you might say, well, the period doesn't have amplitude in it, so does it even change? Okay, and you might get tricked into looking at the equation, but this is actually not a good way of thinking about it because we're not really talking about, the period, yeah, sure, that's not in the equation, but we're talking about how far it gets. What is the amplitude it reaches? Okay, so the first thing you have to really think about here is the fact that this is a collision that we're talking about. So this is gonna be a long explanation, and this is where you're gonna get the bulk of your points. This is a 6-point part because this is just 1 point. The question's 7 points, right? So we got to mention a lot of different things here. So the first thing, and I'm going to write this down because I have some equations that I need to talk about instead of typing it, but the first thing we want to talk about is what happens to the velocity. Okay, so, and I know I need to talk about that because we're talking about momentum, and momentum has to do with velocity, so I know I have to talk about velocity with the simple harmonic question. Okay, so, and then also if I'm talking about amplitude, one good way of thinking about that is through energy. Okay, so let's see if I have enough space here. So first, before I even start writing, I want to talk about what type of energies I have. Okay, so in the system, I have the blocks, or block, whatever part I'm talking about, the spring, earth, which I don't even care about because there's no gravitational potential energy here, the surface, which is fine, that's what it's on, but it's not really that concerning because there's no friction anyway, okay? When the block is at equilibrium, so I wrote a lot here, so I'm going to start erasing some of this, okay? Okay, so when the block is at equilibrium, you should know this is the fastest it's going. And x is equal to 0 because it's at equilibrium. The distance away from equilibrium is 0. So the type of energy it has here is all kinetic. When it's at the amplitude, right here, it stops and then it starts turning around. So I know I have no kinetic energy, but I do have spring elastic energy, or elastic potential energy. So let's say this is at the amplitude. So here I have all gravitational potential energy, and that's the total. And again, there's no work done on the system. At equilibrium, I have all kinetic energy, and that's equal to the total. Now, when I have these two extreme cases, one at the amplitude, one at equilibrium, those are extreme cases because I either have one type of energy and not the other, or the other type of energy and not the other. Okay? So when I have these extreme cases, I can say, well, my 1/2 k x squared is equal to my 1/2 mv squared. And it's important to understand that this k is actually at the amplitude. Okay, so instead of writing x, I'm just going to write a for amplitude. Okay, so this is my original case when my mass is just m. So the amplitude that block P reaches on its own, I'm going to call that amplitude. I should actually call it AP for amplitude of block P. Okay, that amplitude I'm going to solve for right here. So I'm going to cancel out my 1/2, and I'm going to say, okay, AP equals mv squared over k square root of the entire thing. I can simplify that, but I'm just going to leave it as is right now. Okay, so now the total energy changes, yes, okay? But the energy bar graphs, the way they're depicted, does not change once that second block is added. Okay, so what about these values right here, changes once that second block is added? Okay, ask yourself that. And the answer is the velocity changes. Why is the velocity change? Well, we're talking about momentum here. So I have an inelastic collision. An inelastic collision is when they stick together and no energy is lost. Okay, well, technically it's really when no energy is lost. But in this case, they do stick together. So I have my initial momentum, so that's block P, so that's m times that initial velocity, equals, the other block is not moving, it's not in the system, equals, when it is dropped, there's no x value of that velocity, in other words. The total mass of the system, the two-block system, times that final velocity of how they're moving. So now, my masses cancel. My v final is equal to 1/3 the original velocity. Okay? So, again, my LOL diagram, it looks the same even though the total is different. It's still, so it might look like a little bit more total, like that much. But in this case, I still have all kinetic energy at equilibrium. My total's bigger here, but in this case, I have all elastic potential energy. Okay? So the bar graphs are technically the same exact picture. So I'm going to say, okay, well, 1/2, my spring constant's the same. I'm looking for my new amplitude. So that's PQ squared equals 1/2. The total mass is now 3m, and that new velocity is v over 3 squared. Okay, so I'm going to solve for the, I'm going to cancel out my 1/2 right off the bat. I'm going to solve for my amplitude. So I'm going to actually simplify this because I don't want us to get messed up here. This is 3m v squared over 9, which I can simplify to 3, mv squared over 3. Okay, that's what this equals. So what I have here is I have k apq squared equals mv squared over 3. I'm going to divide each side by k and take the square root. Okay, so apq equals root mv squared over k3. So the question is, which is bigger here? Well, this is over 1/3. This is root 3 in the denominator, so this is a smaller value. And maybe that's what your intuition told you. Maybe you thought, well, if there's more mass on this thing, if there's more mass here, it's not going to reach such a great amplitude anymore. Where did I draw that picture? I might have erased it. So it's not going to reach that same amplitude anymore. So if you were to check one off, which one would you check off? This one. Whoops. This one. Because the amplitude of the 2-block system is less than the single block system. Okay, that's great. We did everything, but we need to write this in a paragraph. I'm not going to write the paragraph with you guys. You guys are going to do that on your own. But I will tell you how the points are distributed here by looking at the answer key. So my answer key, I have it pulled up here, and this will be posted on my website. We already did the 1-point situation for the period. Okay, I can't circle on this. Okay, second is, again, you get no points for actually writing the correct answer. So for this question, just because we got this right and we know it's right, and I've basically said everything in order to get that right, I get 0 points just for checking off this answer. Okay, so applying conservation of momentum to the collision, which I did. Okay, whoops. Okay, I need to get my screen set sketch. I did this. Okay, so I get that point. I did this. I said my V final is equal to 1/3 V. I needed to do that properly. So I'm going to go back. I want to go back and forth here. So I'm going to grade myself. And you should too. Like when you do this, you should really try to get out a red pen and grade yourself. I'm going to use green, I guess. Okay, so inelastic collision, I did that. I get that point. I get this point. Okay, what else am I missing? Stating or implying that the system's kinetic energy has decreased. Okay, I think I did that properly. And let me read the next one while I'm here. The stating or implying kinetic energy of blocks right after collision equals maximum potential energy of the spring. Okay, so I definitely did that. I think these two, let me get a better color here. I think that these two are basically done in my LOL diagram. Okay. So note, the previous 2 points can be earned in a single sentence in which one or both the points is implicit. Now realize that I haven't written any words yet. I'm just talking through on how would you solve this problem. You actually need to say the LOL diagram in a sentence. So just because I wrote this here, if you want credit on this AP test, you need to put this into words. Okay, and I know that you guys are all capable of doing that. And then So let's go back. I get 2 points for basically saying this in words, these 2 points. Okay? And if you can write this properly, this is that first point that they were talking about. Okay, and then what else do I need? Let's see. Oh, maybe that was, I think I got 3 points with all of that. Okay, and then the last point is for a logical, relevant, and internally consistent argument that addresses the required argument. I think this is I don't know. But I feel like I got everything based on my conclusion of what I did. I'm going to say this is that last point they're saying right here. And this, I'm going to say is 3 points. Pretty confident I got all the points here. If I can do my math right. No, I did my math. Yeah, okay. All right. Hopefully this video helps you. But you really need to do these problems before you look at my videos. So, TTYL.